Welcome to Math with Mrs. Cox. This is Chapter 8, Check My Progress, that is found on page 575. Let's begin. As you go through these vocabulary words, you need to match them with the vocabulary on, or the definition on the left with the vocabulary word on the right. So I will read them out to you. You're welcome to figure out where they go. Number 1, which is the greatest of the common factors of two or more number? I'm going to give you a clue. GCF. GCF. That should help you out. Number 2, which is a number that names equal parts of a whole or part of a set? Yep, fraction. Number 3, a fraction that is written when the greatest common factor of the numerator and denominator is 1 is written in which form? Which means if you're a ninja, a fraction ninja, and are chopping it down, what is it going to be the simplest answer you can get? Okay, see if that helps you out a little bit. Number 3, 3 gallons of paint are used to paint 16 signs. How much paint does each sign use? Between what two whole numbers does the answer lie? Okay, folks, so you have 3, which looks like this, and 16 wood signs. Now, they're not expecting a great big fancy decimal number. Just keep it simple. There are 16 total pieces, and there's 3 gallons of paint that goes on those 16 pieces. So that's what it's going to look like. If you're going to do a number line, this being 0, this being 1, where is this number going to lie? Because this number is not 16/16, so it's not going to lie past the 1. It's going to lie between the 0 and 1. So you just have to say between 0 and 1. Number 5. Referring to exercise 4, how many wooden signs can be painted with 1 gallon of paint? Okay, between what two whole numbers can that answer lie? So you have 3 gallons of paint that are used to paint 16 signs. So we need to be a ninja and chop that down. So what we're going to do is that we can only use 1 of those gallons of paint. So we're going to take 16 divided by 3. 3 will go into 16 at least 5 times. 5 times 3 is 15. There's 1 left over, right? And they are not wanting us to bring anything else down. So when they have this situation, they want you to use the numbers that you see. So you're going to use this 5, and you're going to put over here and say 5. Then you're going to use this 1, because that is what's left over, and put it on the numerator. Now you're going to use this 3 and put the 3 on the denominator. 5 1/3 of a sign. You're going to have enough to paint 5 whole signs and 1/3 of that 6th sign. Only 1/3 of it's going to be painted, which is going to look silly. But that's all right. That's the answer they want, so that's the answer we'll give. And the answer will lie between, on the number line, if you draw a number line, like 4, 5, 6, it'll lie between the numbers of 5 and 6 on the number line. So to be like, if we divide it into thirds, this answer would lie right about there, about 5 1/3. There we go. Okay, turn the page. Number 6, GFC of each set of numbers. So we're going to do the greatest common factor. So this is where you write the number 36, semicolon, and 90, semicolon. And list all the factors you can think of. So for 36, I know for sure that 1 and 36, then I'm going to have, 2 will go into it. You can use your calculators on this if you need to. 36 divided by 2 is 2, and 18, and 36 divided by 3 is 3 and 12. And 36 divided by 4 is 4 and 9. And I know 6. Ooh, I barely had enough room. Will fit in there. Okay, 90. 90. Well, I know we have 1 and 90. And then let's do 90 divided by 2, which is 2 and 45. Then we divide it by 3. 90 divided by 3. We have 3 and 30. So let's try 90 divided by 4. Nope. 90 divided by 5. Yep. 5 and 18. And 90 divided by 6. Ooh, barely enough room. 6, 15, little baby. Okay, so there is our numbers. So hopefully yours looks a little bit neater than mine. We're going to look here and see that the greatest one that we have coming along through here is going to be this beautiful little 18. So that will be our answer. The greatest common factor of both of those will be 18. Okay, number 7. I'm going to do this work off to the side because I have more room over here. So 16, 24, and 40. It's nice when you do the work the first time because then you might use it somewhere else throughout the chapter. All right, for 16, we're going to have 1 and 16. 2 will go into it 8 times. 3 will not go into it. 4 will go into it 4 times. 5, nope. 6, nope. 7, nope. 8, nope. Nope. Okay, 24. Okay, so we have 1 and 24. 2 will go into it and 12. 3 will go into it. No, it won't. Yes, it will. Haha, 8. Almost made a mistake there. 24 divided by 4. Yep. 4 and 6. And 24, 5 won't do it. 24 divided by 6, got that already. Divided by 7, nope. 24 divided by 8, not going to work. Yes, it will because I already have it down there. And then 9, 24 divided by 9, nope. So those are my numbers. 40, I have 1 and 40. Just go through the rest of the story. So 40 divided by 2, and 3, nope, 40 divided by 4, and 10, 5, yes, 40 divided by 5 is 8, and 40 divided by 9, nope, 40 divided by, nope, that's it, so we have. So the greatest common factor that we have among all of those is going to be, I don't want that color, it's going to be 8. 8. Fabulous. Okay, next. Write each fraction in simplest form, and the fraction is already in simplified form, right? Simplified. Some of you guys forget to do that. So simplified is what you would write if they're simplified. Okay, looking at number 8. 8 over 14. Well, they're both even, so I can be a factor ninja and chop them down. I can divide each of them by 2. So 4 divided by 2 is 2, and 14 divided by 2 is 7. So 2/7 will be my ending result. And number 9, I can divide both the top and the bottom by 5. 15 divided by 5 is 3. 20 divided by 5 is 4. Okay, number 10, I'm looking at this, and I know that, let's see, 7 will go into both of them. I can divide them both by 7. So 21 divided by 7 is 3. 35 divided by 7 is 5. Anya buys a magazine and pizza. She spends $9.75. The pizza costs twice as much as the magazine. How much does the pizza cost? This is where it threw me a little bit. So I was thinking that I would just divide this in half, but that's not true. we need to divide it into three equal spots, because we have 2 here for the magazine that cost twice. The pizza costs twice as much than the magazine, and then the price of the magazine. So we're going to take $9.75 and divide it by 3, because we need 3 increments here. Okay, so dot, 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 splat. First thing we do with a division with a decimal. 3 will go into 9 3 times. 3 times 3 is 9. Drop the 7. 3 will go into 7 only twice. 2 times 3 is 6. 7 minus 6 is 1. Bring down that 5. 3 will go into 15 a beautiful 5 times. 5 times 3 is 15. 0. So the price that we have is that the magazine costed $3. Magazine costed $3.25, but that is not what they're asking. They're asking how much does the pizza cost. So if I do $3.25 plus $3.25, because it was twice as much, I can add those together. So 5 plus 5 is 10. 2, 4, 5. Decimal point 6. So the pizza costed $6.50. That was a brain ache. Brain builders. In a pile of coins, there are 7 more quarters than nickels. If there is a total of this much money in coins, how many total coins are there? How many of each type of coin is in the pile? Guess, check, revise, and solve. Okay, so we have 13 coins. Well, let me think, right? Okay, so we're going to have quarters and nickels on that. And there's 7 more quarters than nickels. I'm going to tell you a secret right now. There's going to be 13 total coins. 13 total coins. So we got to kind of figure out that it makes the amount. So let's do a guess and check. So I know that there are 4 quarters and $1. To get to $2, I'm going to have at least 8 quarters there. Okay. 9 would be $1.25. 10 would be $2.50. 10 would be $2.50. So I'm going to do 10 quarters because it's going to equal $2.50. Then looking at $2.65, I have 15 cents left, so that I would need 3 nickels, and that would be 15 cents. The total of that would be $2.65. And I would have a total of 13 coins. That was a brain ache. You guys did great. Number 13, a warehouse has shelves that can hold 8, 12, or 16 skateboards. Each shelf has sections holding the same number of skateboards. What is the greatest number of skateboards that can be put on a section? Okay, so they have shelves. So you're thinking of greatest common multiple. So we're going to have 8, 12, and 16. They're trying to throw you off by making you visualize shelves, but it's just the greatest common multiple. So we'll come over here. We have 1 and 8, 2 and 4. And that's it. And I have lots of space in between, but that's okay. 1 and 12, 2 and 6, 3 and 4. 16, 1 and 16, 2 and 8, 3, nope, 4, yep, 4, 5, nope, 6, nope, 7, 8, 9, 10, nope. Okay, so you can see that the greatest number that you have in there that they all match is a 4, so that you know that there's going to be 4 skateboards. All right, ladies and gentlemen, nicely done. Please go ahead and turn this in.